Sean Moore, CEO and co-founder, TERN. Yeah, so TERN has developed an independently derived positioning system to ideally replace GPS. And so two of the pillars to the company when we started was, if we're going to provide positioning, we've got to do it with absolutely no signal, which is very difficult to do. And two, we've got to work within the confines of the existing ecosystem of our partners. So if it's OEMs, if it's fleet managers, if it's recycling crews, we have to be able to integrate our solution into what they already have. And so, when you're looking at processing at the edge with that type of computational lift, it's got to be fast, it's got to be very efficient, and it's got to be very accurate. And so we just built an incredible team that was capable of doing that. The major challenge we're addressing within the automotive industry is the over-reliance on GPS. So GPS has got known gaps in parking garages, tunnels, dense urban cities, and ultimately, it was a great technology, but was not designed for complex mobility or autonomy. And so, as we move forward into autonomous vehicles and just more complex downtown environments, we need a technology that enables the advancement of those systems. Intelligence at the edge. That is a huge breakthrough. When looking at how you deploy technology into the automotive space, it's got to be fast, it's got to be very efficient, and it has to be intelligent. And you cannot require significant GPU compute, and so it's got to be able to to work within the current designs of what the OEMs are putting into the vehicles. And I think the value then that's created is you have a vehicle that can effectively think for itself. And so not just being aware of its surroundings, but knowing where it is very important. The three technologies I think would be edge computing, so very fast edge computing. It would be a tight integration loop with the partners, and then resilience. So you cannot have a solution that's out there that is not resilient to the all sorts of potential environments it could be in, such as that parking garage or that tunnel system. And so you bring those first two together to get a product that then has to work in the field across all the edge cases. And so I think that enabling resilience within the stack is something that will be critical as we move forward. It's not another piece of hardware or additional sensors. I think it's true intelligence in that vehicle. It's a vehicle that can communicate to other vehicles. It's a vehicle that's aware of its surroundings. It's a vehicle that knows there's a construction site coming up. And largely to do that, it has to understand where it is. Yeah, I'd say the words that come to mind when I think of ARM is fast, efficient, and local. And that's exactly what we need. And so, when talking about providing position into a vehicle, it has to be real time, it has to be accurate, it has to be continuous. And so for us, ARM is a very logical and natural partner because they provide that platform for us to do that. We're not asking the OEMs to adopt computationally intensive chips or these super heavy algorithms. We need to be able to do things very efficient, make their jobs easier, not add additional sensors or hardware. And so when we look at ARM, we think it's really a ground floor or framework for the entire automotive industry that then we can scale through.